We'll go to your class very soon. So that I see how much work you guys have done. So this was our question last time. So what do we start from? Question 5, guys? Or question 6? Anyone? Guys?
Question 5, sir.
Question 5.
Okay.
Question 5.
All right, thank you. An egg is thrown nearly vertically upward from a point near the cornice of a building. So remember, things are not just mentioned anyhow in physics. So meaning the cornice is the reference point. So the egg just misses the cornice on the way down and passes to a point 30 meters, passes a point 30 meters below its starting point 5 seconds after it leaves the hand, the thrower's hand. You ignore air resistance, which we always do. If there's air resistance, then definitely you know that it's calculus, because it means you have to integrate. So to differentiate. So A, what is the initial speed of the egg? B, how high does it rise above the starting point? C, what's the magnitude of its velocity at the highest point? D, what's the magnitude and direction of the acceleration at the highest point? So D should be the simplest up at this point. D should be the simplest at this point. Why should D be the simplest? Because we already emphasized that motion, where free fall motion, where you throw something or it falls down on its own or you throw it down, that motion is constant accelerated motion. It means the acceleration is constant and equal to gravity. So D should be your simplest. What's the magnitude and direction of the acceleration at the highest point? That should be 9.8 meters per second squared. So let me look for question 5. Pardon me, nalipanga mistake on a foot up. So this is D. So D acceleration is 9.8 meters per second squared. So let me go back to the same question. In fact, nalesanga ne abufi C, you pardon me, na kusanga with reasoning. What's the magnitude of its velocity at the highest point? So you, as you are going through, you should even add D, find the time too. Find the time at the highest point too. So that it makes sense. If you're not mocks over, so I made a mistake on your tutorial. Shapangurulemo ninaka. But maramu chae apa. Even in number C should just be straightforward. I was finding time, but the answer is here. At the highest point, the velocity is 0. At the highest point, the velocity is 0. So when you throw something with a speed, because the speed here is some speed which we don't know, Gawasa iposa, it will start reducing until it becomes 0 at the highest point. Then when it starts falling, it will have the same speed but negative values. Same speed, negative values. Same speed, negative values. When it reaches the point, the cornice where it was thrown from, the speed will be the same as the initial one you threw with, except it will be negative because it will be going down. So why are the speeds negative when it's falling down? When something is falling down, the velocity is but negative. So this answer is not the one, guys. This answer is not the one. What should just be here is the internet wants to start tripping. What should just be here is what is the velocity at the highest point? And the answer should just be 0. When you just see a velocity at the highest point, the answer is 0. So twasanga ko D na C ngotsanga ko A hayi. Kaya mi brain yali ba program do kwamba na A. So ngomva chamva feti D na brain ya ba locked. Okay, let's do B. Let's do B. How high does it rise above its starting point? So with a height above the starting point, let's go to our answer. Remember how high it rises above the starting point. There you are looking for, question 5. The height at the starting point, there you are looking for the maximum height above. So there at the highest point already mentioned that the velocity is 0. So with the maximum height above the starting point, the equation is this one. V squared equals V naught squared minus 2GH. But 2G not to solve it anymore because G is 9.8. So hapa mwene tunapika for 19.6H. These are very acceptable equations. Type them in Google and you'll see that they are acceptable. So at the highest point, the velocity is 0. So you can say 0 equals 18.5 squared minus 19.6H. 18.5 E, sangire muri A. So it's not possible to solve this question if you can only solve D and C, then you go to A. So A was the initial speed. Let me explain A, wangu, such twice over. So they've told us that it has a speed 30 meters below. 30 meter, it reaches a point 30 meters below after 5 seconds. So you go to the equation that has a height and it also has it also has time in it, which is this one, H equals V naught T minus 4.9 T squared. So where there's H, which is displacement in the vertical, you put negative 30. So negative 30 is equal to V naught times 5 minus 4.5 times 5 squared. So when you work this one out, minus 30 is equal to 5 V naught minus, you work that one out. So all we're doing now is just changing the subject to the formula so that we can make the V naught the subject of the formula. So when the 122 crosses the other side, GIOC, so GIOC, it will be minus 30 plus 122.5. So it will be 92.5, then you divide by 5, a quarter 18.5. So this inga taulile A, nishina B ne tawaliye. Because B is asking you for the highest point. B is asking you for the highest point. So what have you up?
Sir,
Yes.
I'm asking if you can go on C because I found out to say I found C wrong. I don't know where I went wrong. I found C wrong.
No, I'm saying C National still apologize. C was asking for velocity in Sanga time. You saw that, yeah?
Oh, okay, sir. So I thought I was wrong.
No, C is velocity. So I said the answer should just be velocity is 0 at the highest point. So by finding, if what you did when finding, wachila solver, nishinawine taudi bwino sana kochi ninebo because inena chasanga if even kai question ndingi but what's the time at the highest point na ina sangire fe this thing. So that's the scenario. So this thing for ability, cross this thing out and just say V equals 0. At the highest point, the velocity is 0. Are we okay, sir?
Sir, what I did is that since you said the ice at the highest point, the velocity is 0. I used the equation that does not involve time. Then I replaced the answer, sir.
Oh, then A answer in but at the highest point, velocity is 0. Nishapo wasanga no kusanga.
Yeah,
are you getting?
Okay, sir, thank you.
Okay, they have asked us
yes,
what
I
is
get,
velocity
sir.
at the highest point.
Okay, I get, sir.
Yeah. So with regard time, this is the only way to go about it. First equation of motion, as long as you know the initial thing. So for that, instead of cancelling this one, crossing it out, just add to the question to say, what is the velocity at the highest point, and find the time at the highest point. So that you solve some more, you know some more. This is the case. So when you find this, maximum height, because at the maximum height, velocity is 0. So you say 0 equals 18.5 squared minus 19.6 h. Then you find what h is. So that's the maximum height. So then the tricky things now are the equations, which are almost always the same. So the equation, acceleration time graph, the acceleration is negative 9.8 because it's going down. That's the reasoning. But you when g ngolanda g kuilanda is positive 9.8. But when it's in action, it's negative because it's going down. It's slowing something. Everything when it's going like it's going towards the center of the earth. So could draw walemba y na x at time a apa waibika, then below my negatives ka point papa ponse if it's a sketch, so you don't draw to scale. Hello, draw a straight line because the acceleration is constant, and it's minus 9.8 meters per second squared. For velocity, could draw a thermal points yabidi. For velocity, wala draw velocity y axis, wa draw ko, then time x axis. So remember the time to reach the highest point. So it was even okay that we found it, because it means we should have found it again. So it's 1.89. Then 1.89 times 2, that's the time it comes back to the cornice. But then now at what, 5 seconds later. So you draw this point, 18.5. Per x-axis, this guy up at this point, velocity is 0. Kai 0 ya velocity yambira hapa, ile hapa mudu, ile hapa mudu, ile hapa mudu. So per x-axis, upo wabika, ile hapa time ya per s point 1.89 seconds. Mwimbote? Then elo wa draw wa line just to meet these points. Pa! Wano kulubya lubali. Cha! Elo tuwafika point yakati kufapa tadi, tuwabika pa 35 seconds. Then you combine to call 30.5, which was in the question. Nishwa draw, guys. Nishwa start draw. 30.5 ni velocity. It's negative 30.5. How do you get that negative 30.5? You do the same. You say V equals V naught minus 9.8 T. So those are the scenarios. So that's velocity time graph. So I'll see if there's something to change there, then I'll give it to you guys. So this is how it is, but the most important points are just this one and this one. So because I think he point in the room. So those are the scenarios. So you just go like that. So 5 seconds later, I think it's 49. So kusabika ko 49. He point in big dog tidy moneka win. So we put 49. Negative 49. Then position time graph is always a quadratic graph. Ilana in parabola. In parabola. So you put 0 per cornice. You put 0 per cornice. Then maximum height. How did we get it? We found it at 17.46. Why 17.46? Then the other time, the same distance, upper number is 0. Nishi. When it reaches the maximum height, it starts to reduce. It starts to reduce up. So, chapo wapanga na parabola. Kuingisha kwa munshi panono because it was there deep on a punch fila rubadi. They are deep on a punch. Then 5 seconds later, ka 30 seconds. So that's the scenario. This is how you plot these graphs. Velocity time graph, maximum height, initial velocity is positive. Let's reduce, but maximum height is 0. Then it continues to reduce in the negatives. That's how you go about it. Are there any questions on the plotting? Are there any questions on the plotting? Okay. Mudizi means there are none. Question 6. Question 6. I will redo some of the things that I've noted there that I should have done well. In fact, I'll just re-edit the question so it makes sense. Question 6. A large border. That's a very lovely border. A large border. So chiri like border is ejected vertically upward from a volcano. So volcano with an initial speed of 98 meters per second. Air resistance may be ignored. Always for these questions. So G equals 9.8 meters per second squared. At what times after being ejected is the border moving with the speed of what's the speed there? Of 30 meters per second. Guys, why is the question saying at what times? Friends. Nishidan, that's at what times? Instead of saying at what time. Hi guys. Tandio.
Even this percentage, so the thing that you do is just the same. Okay. You know that you are going to get X. It is X out of 10.
Yes.
10,000.
Now, 10,000 guys. 10,000 hapo. Nani ashire Mike?
No, sir, he isn't talking to you.
Na 10,000 dalundura. Randa. Guys, nani uli ask a question? Why have we said that what times? Bachibusa. Tandio. Tandio, Mike over here. Yes.
Sir, I think this is because the time was varying as the object was increasing its acceleration.
That Moscow have nice it sungu bachanza teyo yo. Tandio, you want to say something?
I give it a try.
Yes. Tandio, come back your question. Not I can try, sir. Can I try now? Yes. Say. Tandio,
yes, why it says that time because the time isn't one, like it's moving constantly and stopping something like that. So the time isn't one, but the amount of time that which is.
Tandio, mlanda no vilanza ya ufi. Tandio. Tiyo na ene ofuti. At what times does the speed 30? Why are we saying speed? The speed will be the same going up and coming down, but velocities will be different because when it's going up, those velocities will be positive. Then when it's coming down, the velocities will be negative, but the same values. That's why I told you that when you throw with, say, 15, it will still come back again with the 15. Except its velocity, it will be positive going up and negative coming down. So since we've read that it is 98, so 98 will go, it'll start reduce until 0 at the highest point. Then again, it will start being negative, until it's negative 98. So what we're trying to say, at what times means there are 2 times when to have a speed of 30. One, when it's going up, which will be positive 30, and when it's coming down, which will be negative 30.
Yes, sir.
You have to say, can I try again? Can I try? No. Kulande fiachini, mlande fiachini, guys. So fyamfwika. So you put muri equation. Therefore to is equation 6. Muri equation 6 it is question 6. So you see that I just get this equation v equals v naught minus 9.8 t. I want to find time, and there should be 2 times going up and coming down. So if v, this is one I'll be varying. It will be positive 30 going up and negative 30 coming down. So nalaibika hapa nalabika ukufesi nalabika kwa positive 30 nsange nshita. Then nsembika una negative 30 ndakai na yene nshita nsange. Namumbade. So this is the positive 30. So 30 equals 98 minus 9.8 t. When this exchange, you find time, it's 6.49. Then ukufuti usobika negative 30 equals 98 minus 9.8 t. When this one goes this side, E30 are positive. What 128 usange t. So these are the 2 times. One when the velocity is plus 30 and when it's negative 30. The speed is the same. It's just 30 meters per second. But velocity a equatama vectors are directions. Velocity will either be negative or positive. Mumvera guys. Imveka. Vimveka.
Navela.
Asogolele. Anaomi. Ewe mugai mulandecha kumalawi. Avena Naomi.
Navela, sir.
Hey, Monday, yes, Monday.
I have a question, sir.
Yes, she's a question. Monday has a question. I go back to where I saw him.
Where is the 30?
Yes, Monday.
Where is the 30 coming from, sir?
From the question, madam. At what
Where
times?
Where is the 30 coming from?
It's in the question. At what times after being ejected does the boat have the speed of 30 meters per second? Are we okay, Monday? Madam Monday, are we together?
Yes, sir, we're okay.
All right, nice accent.
Yes.
Okay. So B, when is the velocity of the border 0? When? Not at what time. When is the velocity of, so when, number word when, it means time. So in at Sovapo, at the maximum height, the velocity is 0. Therefore, so when is the velocity of the border 0? Therefore, was cut at the maximum height. Box of an inch when is time? So you will come to question 6. When is the velocity of the border 0? Ni answer. Answer ni then we change. So being a sin just a switch. We change. Remember, guys, I want you to switch them. Oh, B is when is the displacement 0? Then I'm okay. So when is the displacement 0? You say H is displacement equals V naught T minus 4.9 T squared. So ukuku the H walabika ko 0. Then C is when is the velocity 0? You get this one, V equals V naught minus 9.8 T. Ukuku the V walabika ko 0. So you have 0, you don't cross out, you factorize in physics. Why? Because 0 is a very important answer also. When you cross out, you cancel out time where you wasanga. So you always factorize. That's why they factorize up. T, nashta isolate T, then 0 equals T, open brackets 98 minus 4.9 T. So T is equal to 0. The velocity, the displacement is 0 per kwamba. Then also 0 equals 98 minus 4.9 T. We solve for 4.9. For T, you find 20. The 4.9 crosses the equal sign. So the thing you perfect is just to change the subject of the formula. Then when is the velocity 0? 9 and the same. Penapa cross of 9.8. So after 10 seconds. It even makes sense. Why? Because when going to the highest point, it takes 10 seconds. When coming back to the point it was thrown to, it also takes 10 seconds. So the time, iyi nefe nga mwalipia sa nefe, nga wasanga fe iya displacement 0, nga divide fe by 2, you get the point, the time when the velocity is 0. Why? Because that's the maximum height. So it will take the same time going up to the maximum height and coming down to the point it was thrown. That's how it is. So that's the scenario. Then find the acceleration called mass 18. Ukusabika max ama nani ya tatu. Box by maybe people. Find the acceleration when it's moving upward, downward, and at the highest point. Doesn't matter, guys. Doesn't matter. Acceleration is always constant. It's 9.8 meters per second squared. Then the plots. The plots, name is of Velapokale, I'm a plots. Malam prote. I have question 6. These are the beautiful plots now. Question 6. So, acceleration, you plot it like that. Position, quadratic parabola, like that. This is the maximum height. So, kusangona ka maximum height pakchwa kabiko kukafona inte. Then you go like that. Velocity I said, kubura fe initial, then na time at highest point. Then na time at highest point, is sharp. Mwambia plotting you go and go through, but these are the shapes. Velocity time graph goes like this. Goes 0 nishijapale by highest point. Then it goes down. Kai bambi want to highest point hiti muishi bambia ni velocity to the land up. Velocity is reduce. Bambia banom to wakomeka because highest afili alefo kuimwena pamuro highest. So that's the scenario. So those are the things. I add the next guys mark quiz, mark quiz. Yena mwalamu has to figure out mwevenu. Mwavale? Are we together? Mwava guys? Question 7 and 8 are quiz questions type like Yakuton.
Sir, I want to ask on the graph.
Yes.
Sir.
Bachongo.
I want to ask on the graph.
Yes.
Yes. Those graphs, are they specifically like the graph of velocity is like this, or the graph of acceleration is like this? Can you master them? That
yes.
The graph of acceleration looks like this.
Yeah, acceleration is what is what. They are like that.
Okay.
Always.
Okay.
Yeah, acceleration is a straight line because acceleration is constant. So we have a straight line punch by the x-axis. Remember? Then here position even quadratic. Fly monica bueno quadratic. Parabolic.
Parabolic.
Remember?
Yes.
Then here even straight line. Velocity time graph. Even straight line. Ida velocity batch to pera 98 hapa kwa mbira. If you have oxide. Then time hapa highest point hapa pakati hapa. Elo washira film line was straight. Ni sharp. Ofo ya were fixed. Are we together? So for the next question,
yes, sir. I'm clear.
Right. For the next questions, these are quiz type questions. You have got mass 18 and quiz type questions. But over teaching to Chile upon then it covers 60 meters during the last 2 seconds. So you see how I did my answers. The answers are correct. The answers are correct. Then napapasan that the mweri webadi posa, the mobile posa pamul, the mobile posa put the modi upon punch. Erofia punka na after 2 seconds. Everybody 2 seconds modi tutorial. So what is the initial? Here is the pose lady. So wala sanga. One, what you find ni distance after 2 seconds. Wala sanga ka distance kai then ufumieko ukabonfia namba kudi e. So those are the things. Go and go through these things. Time is not always our friend. This I'm a quiz type. Taesa is no quiz is to become office just for you to know that there's diversity. Taesa sana modest because the L9 is a quiz type, guys. Na shira isangira fenemwene. Equation 7 that side etapo 2012 2011 nairete 2012 narete inangu nasangire feneka tapadi student wasangire yo barikana fienu fyo basa. So those are the scenarios, but these are quiz type questions. I won't delve in them so much, but those of you who would love to go through, you will go through. They are part of the tutorial. Turabika fino tuntua kwa tikawanya fe tutorial isule bueno. So ya ututubiri. But the key things we've done together. I want the next 2 seconds, 2 minutes, umuntu asukeko. Guys. Epusheko. So anyone to ask the questions? Anyone to ask? So to conclude, acceleration is constant. It doesn't matter when you are asked when the acceleration is. It will always be 9.8 meters per second squared downwards. Then the velocity is always decreasing. It's always decreasing when you throw something up. So it's decreasing. Even when you throw it down, it's always decreasing. Why ikara chepa for velocity? Ide chepa for until the highest point. At the highest point, velocity aruka 0. Then after the highest point, from 0 number, it will be negative coming down. So the velocity is positive going up, positive and reducing going up, negative and reducing coming down. By reducing negatively, we mean initially kurama negatives. You know, negative 10 is less than negative 5. So that's the case with the velocity. With displacement, it's the same. Displacement, it will go up, positive, very positive. Ero yafika pa highest point. Futi yambo study juicy. Let's study juicy. Paka yaba 0 para wachiposela. Para wachiposela nishi yaba 0. So that's the reasoning that is there. So always master those, write them somewhere. At the maximum height, V is 0. Remember, at 0 displacement, it's the point where you throw from. Write all those. Then acceleration is always constant. Then write your equations somewhere, these ones. Always. These guys are very simple concepts. I don't want you to be struggling to be solving. You guys are very sharp. You are the most intelligent I've ever taught. So just know that. So go through these things, try to analyze them on your own, and it will be very easy. So the key is just to master what equation to use and when. I will continue to guide you. I'm wise here. So thank you very much. Enjoy your day and sharp. Okay? Mom for